Hello, everyone. Sometimes it's important to get the equation of a tangent line or the slope of a tangent line of a curve at a certain point. To do so, we have to use derivatives to get that slope and then combine the slope with that point to compute or obtain the equation of the tangent line. So in this video, we're going to be using derivative techniques that we've learned so far on how to compute the slope and then get the equation of the tangent line, and then verify that by using a TI calculator. Okay, let's begin. So to get the equation of a tangent line, we need a slope and a point. Usually the slope at a point of a curve tells us basically the rate at which the function is changing at that point. It has a lot of physical applications, okay? But we still use derivatives. To compute the slope, we have to get a derivative and then evaluate it at a point. And we have to go through, again, either this set when our argument is just x, or a function of x, in this case, the chain rule. We still have to use product rule, quotient rule, chain rule, implicit differentiation, logarithmic differentiation, whatever it takes to get y prime or dy dx as a function of x and sometimes y, and then compute the slope at a certain point. And from that, we use the point slope form or the slope intercept form, whichever form we want to use to compute the equation of a line. So let's start with just a very simple example. And let's begin, by the way, again, y, in this case, everything is a function of x, and y prime and dy dx are interchangeable. So let's look at this one, this equation. So here we have a circle. X squared plus y squared equals 25. We have a circle centered at the origin with a radius of 5. And at x equals 3, we would like to evaluate the, get the equation of the tangent line. But if we draw it, okay, this is 5, because it's centered at the origin right here. 3 is here for x. So we're going to have a tangent line like this and a tangent line like that. So we have two tangent lines here at x equals 3. So that's why we could, for this problem, we will get two tangent lines. All right, let's go ahead now and do the evaluation. The first thing we got to do is get the derivative. So 1, get y prime. Okay. Then we get m, this is the slope. Okay. The slope at the point x equals 3, or at the value x equals 3, and then some y value, which we'll evaluate in just a minute. Okay. And then 3 will get the equation, get equation of tangent line. Let's do it. So y prime. As we can see here, it's easier to do implicit differentiation. So again, y is a function of x, implicit differentiation. So we'll have x squared prime plus y squared prime is 25 prime. Derivative of x squared is 2x plus derivative of y squared is 2y y prime, chain rule, is 0. Okay. And in this case, y prime, let's solve for y prime, right? So y prime is negative, the 2's cancel out. So it'll be a negative x over y. There's my derivative. Okay, negative x over y. So obviously I cannot get y prime without knowing what y is. So how do we get y? We use the original equation to get y. So at x equals 0, 3, I have 3 squared plus y squared is 25. Y squared is 25 minus 9, because 3 squared is 9, which is 16. So y is plus or minus 4. So this point right here is 3, 4, and this point is 3, negative 4. At the 3, 4, I expect a negative slope for my tangent line, and the 3, negative 4, I expect a positive slope for my tangent line. Let's go ahead and compute those tangent lines. So now since we have 2 points, let's be specific. So at the first point, which is 3, negative 4, 3, 4, the top one, m, the slope, is y prime, negative 3 over 4, negative 3/4. So now we have a point. Look here, we have a point, and we have a slope. This is the slope. That's the point. So we could use the point slope form, which is, we'll do it 2 ways. Y minus y0 is m times x minus x0. This is my x0. There is my 0. And the slope m is negative 3/4. And m came out to be negative 3/4, which is a negative slope for the point 3, 4. And this was our assumption here, that the line is going to be going down like this, and it's going to have a negative slope. So we're on the right track. Let's continue. So y minus 4 equals m, negative 3/4, x minus 3. Multiply things out on the right, then bring the negative 4 over. So y equals negative 3/4 x plus 9/4 plus 4. So we have negative 3/4 x. And then here, 16 plus 9 is 25/4. Okay, which is 6.25 here. Here, negative 0.75. All right, let's try it a different way. This is for just the 1 point. Okay, we have another point. Let's try it using y equals mx plus b. Okay, so m is known. We need to get b. Okay, so at the point 3, 4, you plug 4 in for x. 4 for y and 3 for x. This is here, negative 9 over 4 plus b. Bring this over, comes plus 9/4. So b equals, again, 25 over 4. So now go back to this equation and plug in what m and b are. So y equals negative 3/4 x plus 25 over 4, which is exactly what we got over here. So either way will work for you. Whichever one is easy, just do it. Okay. So here's the first tangent line. Let's do it for the other point. The other point is down at 3, negative 4. So at 3, negative 4, remember y prime, the slope, was negative x over y, which is negative 3 over negative 4. So negative right here. Sorry, 3 here. Which is 3/4, which is positive, which is exactly what we thought would happen if this is, this is a positive slope line. Same approach. I'll use this one right now. Again, y minus y0 is m times x minus x0. With this being my x0, this is my y0, and obviously this is m. So it'll be y minus y0 is -4. So minus -4 equals 3/4 x, sorry, 3/4 times x minus 3. So you will have y. When I bring this over, it becomes a -4. So we have 3/4 x minus 9/4 minus minus 4. Okay. So this is 3/4x. And then here I have minus 25/4. Mhm. So we have two equations at the 2 points. Let's see if we use the calculator, we will be able to verify this. Okay. So here's the calculator. Let's go ahead and plug in the function. So again, this calculator here, it needs y equals something. So what we were given, x squared plus y squared is 25. So we can solve for y squared is 25 minus x squared, and y is plus or minus the square root of 25 minus x squared. So it's not a function, actually. It's just a relation between x and y. However, we can plot it one hemisphere or one half circle at a time. We can plot the top one, get the slope at this point, then plot the bottom one and get the slope at this point. Okay. Obviously, the plus, if y equals the square root of 25 minus x squared, that will give me the top part. And then y is negative the square root of 25 minus x squared. That will give me the negative part. So let's go ahead now and put it in square root 25 minus x squared. And let's graph it. There is the top one. Awesome. So now let's go ahead and compute the tangent line. Let the calculator do it for us at x equals 3. So here we do. See this draw right here in blue, cyan? So we have to click the second to get to draw. In 5, it says tangent. So we hit 5. Now we just pick an x, just type it in, 3. Enter. There's the tangent line coming in, and here's the equation. -3/4, which is -0.75, plus 6.25. And 25/4 is 6.25. So this one checks out perfectly well. Let's try the other one. The other one was, let me move this here out of the way. The other one was the negative, with the negative. Okay. So let's go here and go y equals. And I just want to insert a negative in front of this one. So maybe I can try it this way. Enter. All right. So now let me graph this one. And that's the bottom half of the circle. And now let me again repeat the process for x equals 3. So second, draw, right? I want to get the draw right here. And then pick 5. Or you could hop down to 5 like this and hit enter. Either way is fine. And now let's put 3 in here. Enter. There's the other tangent line. And again, it's 3/4 right here. I have part of the equation showing, minus 25/4, which is 6.25. So this one also checks out. Okay, so that's how we do it. It's always good once you've done that much math. It's good sometimes to get a verification from something like this calculator, or I'm sure there are other online calculators that will let you do those, and we'll introduce them as we go along throughout this math and physics and series. So, but this is the easiest to begin with. So here we are. We just computed that. Let's move on to another problem. So I have something a little bit more complicated. Y is e to the negative 3x root 1 minus 2x squared. And we want to find the equation at x equals 0. Same thing, basically find y prime, then get m at x equals 0, and whatever y we need to. But here y equals something. So let's find y first. We know we need y, right? We need a slope and a point. We're not given a point, we're given the x coordinate of that point. So let's go ahead first and find y, get it out of the way. So let's get y first. So we plug in x equals 0, at x equals 0. So y equals e to the negative 3 times 0 square root 1 minus 2 times 0 squared. This is 1 and this is 1, so y is going to give me 1. So the point is 0, 1. So this is my x0, y0 that I use to plug into my point slope formula or slope point formula. Okay? I've seen it used both ways. So let's get y prime. So y prime equals, now what do I see here? Let me rewrite y here as y equals e to the negative 3x 1 minus 2x squared to the 1/2. Okay? Let's bring it over here maybe, if we can. No, that's not gonna let me do it. So let's write it here. E to the negative 3x 1 minus 2x squared to the 1/2. Again, as I mentioned in the video about chain rule, we don't really see any chain rule here or anything. The first thing we see are two functions multiplied. Then we use the product rule. So y prime is f prime g plus g prime f. Definition of the product rule. So here e to the negative 3x prime times 1 minus 2x squared to the 1/2 plus g prime 1 minus 2x squared to the 1/2 prime times g. All right? So now we can easily start looking at this and that separately. See, what do we have here? Exponential to something. The derivative is itself times the derivative of that something. And here I have 1 minus 2x squared to the 1/2. Plus, here I have a function of x to a power. So power rule right away. So it'll be 1/2 times 1 minus 2x squared to 1 less power times the derivative of the function itself times e to the negative 3x. We have two more derivatives. 3x gives me a 3 when I take its derivative. Here 1 minus 2x squared to the 1/2 plus, keep this the same. What's the derivative of 1 minus 2x squared? Is 0 minus 4x, right? So it's negative 4x. And then here e to the negative 3x. You can simplify a little bit. You could maybe factor out e to the negative 3, bring this down to the denominator and get a common denominator. But that's not the point here. The point is to get the slope at x equals 0, right? x equals 0. So let's just plug x equals 0 in right away. I've finished taking derivatives. You can simplify if you want, but I wouldn't. I'll just say add x equals 0. M, now I call y prime m, because now I'm specifically using it at a point. So what do I have here? 3e to the 0. So that's 3 times 1. 1 minus 0 to the 1/2 times 1 plus 1/2. 1 minus 0, that basically the 1 over the square root of 1, which is also 1. Here times negative 4 times 1. 4 times 0. Because x is 0. And then I have negative e to the 0, which is 1. So obviously, this term goes away because of this x right here. 3 times 1 times 1, which is 3. So y prime is 3. So m is 3. Again, if I made any mistake here, hopefully the calculator will show it to me. Now I'll go back and I'll redo my math real quick. So now that I know the slope, I know the point. I just computed the point. I can use the point slope form, which is y minus y0 is m x minus x0. Now he would say, get the equation of the tangent line. So y minus, what was y0? Where is it? Here, 1. M is 3. X minus x0 is 0. So y equals 3x plus 1. Is this the equation of my tangent line at x equals 0? I don't know. Unless I go back and double check my math. This could be a mistake here. So now it's calculator time. And then with the calculator, we can double check. If I made a mistake, I'll find it and I'll go back and fix it. So let's clear this and write down what our original equation was, which was e to the 3x. So second e to the negative 3x, right? Or 3x. Did I make a mistake here? I just found a mistake right now. Negative. So it should be a negative here. Should be a negative here. Negative there. Negative. Negative. So that's good. Because now, again, yeah, it's e to the negative 3x times that. Okay? So let's plug that equation in. So e to the negative 3x, and then square root 1 minus 2x squared. Let's graph it. Okay. Because of the square root, we only have a very short domain. And let's look at x equals 0. So let's zoom it in a little bit. Let me fix my window maybe in the x from negative 2 to 2. And let me do the y from negative 2 to 2 as well. The y is positive. Let's just try to center it a little bit so we can get a better feel. Right? Goes up, comes down. So I'm looking at the slope at this point. So now we go second, draw 5 for tangent at x equals 0. It's been selected, but just to double check, put 0 in, enter. There is the tangent line, negative 3x plus 1. So if I did not catch that mistake while I was putting the function into the calculator, I would have looked here and I said, oh, 3x plus 1. I'm missing a minus. So I got to go back and double check my work. I know what I've caught it right about here. When I'm taking the derivative of the power is actually negative 3x instead of 3x. Okay? So this is how we do let's do one more problem. Okay. So we have root of 3 minus x, e to the sine x squared minus 1 at x equals -1. All right. So we know we have to compute y, because again, we're only given x. So let's just find y at x equals -1. So we'll have f of -1 equals the square root 3 minus -1 e to the sine -1 squared minus 1. Well, -1 squared minus 1 is 1 minus 1, which is 0. Sine of 0, which is 0. So here we have square root 3 minus minus 1, or 4, e to the 0, which is 2, right? Square root of 4 is 2, e to the 0 is 1, we get 2. So the point is -1, 2. We need a slope. We have a point, we need a slope. So get f prime of x, or y prime. So f prime of x, again, what do I see here? I don't see a root, I don't see an exponential. I see one function times another function, immaterial of what they're composed of. So this is my f, and this is my g. Right, so the derivative is, sorry, let's not use f because the function is f. Let's call this h. So it'll be h prime g plus g prime h. Derivative of the first times the second plus the derivative of the second times the first. Well, the first is a root actually, so let's make it to the 1/2 power. So it's 3 minus x, so 3 minus x to the 1/2 prime times the second function plus the derivative of the second function times the first. And the first was the square root of 3 minus x. All right? Again, we're just applying, the product rule. And that's what we have. All right, so now let's concern ourselves with the actual derivatives, not applying a certain rule. Although we may still have to apply other rules as we go down, basically into the rabbit hole of chain rule. So here, what do we have? Again, first thing we see, not 3 minus x to a power. I see some function to a power. So the derivative is drop the power, that thing to one less power, times the derivative of that thing, times e to the sine x squared minus 1. Okay? Let's see if I can. Move things down a little bit. All right. Much better. Plus, now I'm here. I have e to something. The derivative is itself times the derivative of that something. Times the square root of 3 minus x. Right? Again, this is this, and this is this. Okay? Those are the two derivatives we have. Well, let's continue. Okay? So now we come here, 1/2. This is like 1 over the square root 3 minus x times the derivative of 3 minus x. That's just -1. And here's my exponential function. plus, here's the exponential function again. Not sure why I did this. There we go. Now, there's no derivative on the first term. Derivative is here. What do I see? I see sine of something. It's the cosine of that thing times the derivative of that thing. Root 3 minus x. One more derivative. This minus, I'll combine it with the half and put this over here. Actually, I can factor out me to the sine x squared minus 1. Here I have a negative 1 over 2 square root 3 minus x plus cosine x squared minus 1 times the derivative of x squared minus 1, which is 2x, times the square root of 3 minus x. And I'll just leave it at this. I don't want to simplify it anymore. Now, f prime at 0. Find me the slope at x equals 0. So here we have e to the 0 because, again, let's explicitly put it. Sine 0, sorry, x was minus 1. X was negative 1. So at negative 1. I need to find the slope at negative 1. So e to the sine, negative 1 squared is 1. So that's going to give me a 1 on top. You have 1 over 2, 3 minus 1, plus cosine. Here's going to give me a 1 minus 1, which is a 0. 2 times negative 1, square root of 3 minus 1. Here's a 1. Times 3 minus 1 is 3 plus 1, which is 4. Root 4 is 2. So I minus a quarter. Plus cosine of 0 is 1. 2 times negative 1 is negative 2. And I have a square root of 4, which is 2. So I have negative 4 minus 1/4. So that's negative 9/4. So that seems to be my slope. Okay. So now I gotta get the equation of the tangent line using this slope and the point up here, negative 1, 2. All right. So let's go ahead and again the equation of the tangent line, y minus y0, mx minus x0. And again, I'll use the calculator to see if I made any algebra mistakes. And then I'll go back and fix them. So y minus y0 is 2. So let's put 2 in here. M is negative 9/4. X minus x0 was negative 1. So y equals negative 9/4. Here I have plus 1, so plus 9/4 and plus 2. So negative 9/4. Here we have plus, x, 9/4 x. Plus, this is 8 plus 9 is 17/4. So this is 4.25. And then this is negative 2.25. So let's see if the calculator gives us that. Okay. And it's good to see it as well. See how the function looks. So let's grab the calculator and plug that equation in there. So clear. Okay, so he will have the root of 3 minus x, and then the exponential of sine, where is it? Right here, of x squared minus 1. And let's graph it. And then I need to be in the vicinity of -1. So here's 0, here's -1, -2 from my window. That looks okay. And again, if this is my -1, let's make the y function, let's make y a little bit higher. So y, let's just start maybe from -2 to 4. Graph it. So here's my -1. The function is at 2. So at this point right here, there's a tangent line going like this and has a negative slope. And look what I got for my equation of tangent line. Is negative. Okay. So now I'll just go ahead and do it real quick. So second, draw 5 at -1. It drew it for me and it gave me the equation -4.25. So I made a mistake somewhere. Then I have -2.25. Okay. So hold on. Let's see what we found. Let's first make sure we got the equation incorrectly. Looks like we did. So let's see where I made a mistake and then see if we can fix it here real quick. So could it be in the derivative? So this one, that seems correct. It's going to be a -1. And here it's going to be a cosine times 2x times that. So far, so good. And let's plug in -1. Again, this is a good technique for you to learn to go back and double check things. Okay. Wait a minute. Let's see. What did we get? Okay, graph. Second. Let's see how far off we are. Need the equation of the tangent line. Here we go. 4.25. So the denominator here should be 2, at least for the first one. So let's go here. Okay, here's the 2. And 2 will give me a 4. Excellent. And here I have a 1. And here I have 2 times 1. -1 is -2. And here comes 2, 4. Here's a negative. Okay. So that is the slope. I'm not seeing it. This is 2. Okay. 2, 2, 4. With a negative, that's 1. Here we have 1. -2. And 2. Okay, I found the mistake. This was right here. -4 minus 1 over 4 is actually -17/4, which is -4.25. I want to keep this in the video because I want to show you that, yes, mistakes happen, but it's always good to have something to go check what you did to show that, hey, you know what? Let me go back, revisit my work. Let me check what I put in the calculator, see if it's correct, and then so on and so forth. So let's do this here. So here we'll put 17, and then here +1. So let's go ahead and, so here's 17, right? Because that's a +1, +2, and then what do we have here? Bring the 2 over. So that's 8 So 25 over 4. No, sorry, negative 17 over 4 minus 1 plus 1. So 17 over 4. Bring the 2 over. So that will be plus 8 and 17, 25 over 4, which is 6.25. So let's double check with the calculator again. Where's the calculator? Right here. Still have an error right on this side, right here. So I got this. Now I want to get this correct. So this is correct now. Let's double check that y is 2. Y is 2 actually. So that is correct. Because when I plug in negative 1 here, I get 1 minus 1, I get 0. Sine 0 is 0, e to the 0 is 1. 1 minus 1 is 1 plus 1. 3 plus 1 is 4. Root 4 is 2. So negative 17 over 4 times x. Negative 16, negative 17. And now, again, let's do it proper. Negative 17 over 4x, negative 17 over 4 plus 2. And here I have 8 minus 17 is negative 9 over 4. So there it is. Now it's fixed. So now we have the proper equation. Again, algebra mistakes from here on, arithmetic mistakes. Good to have a calculator to go back and redo your work to match it. But of course, you got to make sure that you put things correctly into the calculator in the first place. All right. So I hope this was beneficial in more than one way. And I'll see you later in another set of videos on derivatives and tangent lines. Okay. Thank you. Bye-bye.